Thank you, Mr. Chairman. Mr. Chairman, ladies and gentlemen, thank you for your insistence for the last section, last minute of the conference. Okay. This is Wang from Department of Refrigeration, Air Conditioning and Energy Engineering, National University of Technology, Taiwan. Today I'd like to talk about preliminary study about the feasibility assessment for hospital. Actually, it's an old hospital but still under operation. So we need to talk a little bit about that one, especially through the energy modeling and also the field study. On my online agenda, including the motivation and the abstract of the study, and I will give you some brief introduction about background and also some study. Then I will talk about the hospital system, and also we did for energy modeling, how to manage it, and give you some result and discussion, and then make a conclusion. Okay. The objective, including the field investigation and the energy modeling, to evaluate especially the feasibility of retrofit of energy efficient hospital in Taiwan, because we kind of back of the energy power shortage as well. And the hospital consume a lot of energy, as you can see annually, 8 million kilowatt hours. It's a large area of storage. And the retrofitting plan of the facility system become quite crucial for the hospital, how to make it more energy efficient. So recently we got some application from Ashley. It's called the PCBEA. It's a procedure for commercial building energy audit. So they provide procedures for us. Right now, even the lead system, they adopt this kind of system. So through the field study and energy audit, we can collect a lot of information about the building geometry, material, space type, power density, occupancy, and also as the cooling load situation, and also the operating schedule of the lighting and the facility, and so on. So through the energy consumption baseline, then we can derive from the PCBEA and also the building automation system, because we try to have some data to calibrate our model. So energy modeling using Energy Plus has been conducted extensively at the third stage to evaluate the energy saving approach. Actually, we evaluate a lot, but I just try to show you some. The result reveal that, for example, you can increase the chiller water temperature, especially during the all-peak season, for 1 degree Celsius, and you can obtain 2.1% of annual energy saving, and also you can reset your room temperature for 1 degree Celsius to obtain like 1.1% energy saving. So apply some like film for the glass, because it's all buildings for the retrofit. Here we can get like 1% of annual energy saving. However, the film is quite expensive, so we will talk about that one as well. As you can see, the energy is decreasing. It's increasing. Okay, so the big demand increase. However, the power generation is almost there, so our margin become less and less. So this is also a crucial problem for our government. So we need to think about the energy efficient building, especially for the old hospital. So according to the Bureau of Taiwan, there's about 145 hospitals. Most of them are under operation. Is the old one, especially is about 800 kilowatts and consume roughly 2.1 billion kilowatt hour per year. Is approximately about 50% of all the industry, non-industry sector in Taiwan. So the average UI For the medical center and the regional hospital are about 245 and 200 approximately respectively, about 1.5 times of the normal commercial building, which means dramatic energy consumption, energy intensive as well. Here are some literature review about the energy modeling, especially on the hospital building. So it's not a new one. However, and also from this kind of survey, you realize it is widely set to use for the energy demand and potential saving for office building for energy modeling. So we also adopt the energy modeling to try to survey for this one, using a more practical model. And you can see that the modeling for the energy efficient of HVAC system also by some researcher as well. Then for the X-ray in 2012, they have a green box because the color is green, so we call it the PCPA. So we don't want to go into detail for this one, but as you can see, they got some procedure and a guideline for you to follow. Okay, so roughly you have a preliminary energy use analysis about the energy flow, and the first one you have to walk. You spend a lot of time to walk through for the analysis on site. Then for the first two, you go for energy survey analysis about the energy flow. Then you go back to your lab to do some detailed analysis, especially for like a capital intensive modification. For example, you try to retrofit or renew your chiller. It takes money, right? So they will go for that one. They've got a procedure to do that. So the field study and energy audit will conduct to collect all this kind of information. Then we go for the system description of the building. Actually, the building is located in the middle of the Taiwan. It's a central part, hot and humid weather condition, which consume a lot of energy for the HVAC system. The left part is the snapshot of the building, and we also have the 3D model from the energy class. From the B2 to 12 floor, roughly the description is like that. The first floor, the second floor is the lobby, outpatient area, emergency room, and the third floor and the fourth floor is the operation room, which also energy intensive. And then we have some wards, including some negative pressurized isolation room. And also on the top floor is the administrative one, got some office there. And the first step, we have some construction information from the building. So that's the U value from the roof. We have checked with the architect, and also we have some from the exterior wall. Maybe not so precise, but it's quite important for us to calibrate our model. And the wind glass as well, using the SHGC is about 0.5, which is not so efficient, but it's existing building. Here are some interior load for the buildings, including all the people at the maximum, and the lighting density, and the electrical equipment density in detail. Also, we check about the schedule, including the people occupancy. Sometimes it varies, but we try to calibrate as more as possible. So we have spent a lot of time in survey on this one. Also the lighting schedule, and then we will show you some schedule to make you more visualization of internal electrical equipment schedule, because it's quite important for us to input for the energy model, and also for the air conditioning system schedule. And we also separate it in Schedule 1 and Schedule 2, which represents is a weekdays or weekend or holiday, because the loading pattern is different. And also some activity factor was used for calibration because some emergency room, intensive ICU, and also for some operating room are 24 hours. So we have to calibrate that. So here comes the occupancy schedule during the 24 hour in different areas. And also this is a typical one for most of the specs. Okay, actually it's quite time consuming, but we have to put all this kind of schedule in the energy model to make the models more precise. And this is the lighting schedule for the 24 hours, including the weekday and the weekend or the holiday. We try to put it in the energy model. Figure 5 shows that is an internal electric equipment schedule, and figure 6 is the air conditioning system schedule. Okay, during the weekday and during the weekend. And here is the HVAC system flow charts, including 540 refrigeration tank chillers in parallels, and also 250 refrigeration tank chillers for 24 hours. The COP is not so high, only 5, but it's IP a week, okay? Mine is the full load capacity and efficiency. So if possible, we try to evaluate in advance. If we try to improve the COP to retrofit a new one.
Is it a water-cooled chiller?
Water-cooled chiller. But it's a full, it's not IPL, like double efficiency. Also the primary secondary system with the chiller pump, the same as most of the system. Okay, they got already some like VWB energy saving strategies, and also some clean towers, because you have to put all this specification, including the air handling unit, in the energy model. The specification of the chillers. Okay, similar. The efficiency is not so high because it has been operated for maybe 10 years. Okay, the typical chiller supply and the return temperature, and for chillers and also for the cooling tower. Then we try to set up the baseline model. Okay, so in order to have a very comprehensive energy consumption data, especially for electricity consumption, so we choose 2015 because actually 2016 we had also, we cannot calibrate this very precisely due to some operation termination in the hospital. So, but after the very time-consuming calibration, we can have some simulation data, and the actual measurement is about 3.6. Normally it's over 10%, but we try to calibrate this model within 10%. Okay, I will show you some results here. Here is the best one we can have. 3.6 is quite difficult, quite challenging for us. Normally we have over 10%, and we have less than 10%. So it's kind of average. But it's good to see after our calibration, the annually energy consumption data from the electricity bills and our simulation data from the energy modeling pretty much acceptable from the engineering aspect. And after this kind of evaluation for the energy saving measures, we try to, actually we access about 20 measures, but I just show you this kind of strategic approach. How can we use this kind of energy modeling in the real project to evaluate any feasibility for the retrofit? So the baseline is the energy cost building model with the current internet system, which has categorized monthly with the electricity consumption in 2015. As you can see from some major here, we calibrate monthly from the baseline in 2015. Then we have a major 1, major 2, and a lot of different approach. As you can see from the major 1 is to try to repress the 250 refrigeration ton from the old chiller COP 4.0 to 0.5. From the energy modeling, you can evaluate that energy saving. If this model is after calibration, the energy saving roughly about 3.8% energy saving. But you have some investment, so the return on the investment, which is ROI, is roughly about 2.6 years. Okay, which is acceptable because it's a small chiller. For the huge chiller, maybe longer. For the major 2 is increasing the chiller water temperature, especially while it's or peak. For example, it's in early morning, it's not so hot. So we try to increase the water temperature for 1 degree Celsius. So you just change the schedule very easily. Then you can have about 2.1% of electricity saving annually. Because only for the adjustment, you don't have a lot of investment, so the ROI is quite good, 0. It's from the management. So for the major 3, we try to have like decreasing the water temperature by peaking for 1 degree. You can still get a 1.1% of energy saving for the annual electricity. So we calibrate it every month. Then the major 4, we try to have some window glass film, insulation film, from the SHGC from the 0.8 to 0.5, which is not so good but acceptable one, with some saving about 1%. But the film in Taiwan is very expensive, and the glass area is quite huge, so the ROI is not so good. So it strongly depends on the cost. So in this study, we just try to show you the strategic approach. Okay, you can use kind of like this way to do the energy saving evaluation, including the investment as well. And then we also have some strategic plan about the lighting system from the TA, the major 5. And then you can see the annual consumption. Like energy saving for the annually is about 3.8% with the ROI about 7 years. And the major 6 is about the high performance appliance, including the power factors and the demand control system. It also can have about 1.6% energy saving from the electricity bills, and with the ROI roughly about 5 years. Major 7 is a little bit unreasonable, but I still try to show, because just too many fans in the hospital. So even you try to have the efficiency from fan efficiency from 0.6 to 0.7, the total saving is about 0.2, but just too much investment. So the ROI will become very, very high. So if possible, we just try to delay like this one. Major 8 is about the indoor temperature reset. Right now it's quite popular in Taiwan because you don't have to spend a lot of money. Okay, but what we did is reset for 1 degree Celsius only during the not the very hot season, the off season. Okay, for example, in the afternoon we cannot reset, but in the early morning and the late afternoon we can do that very straight. The total energy saving is 1.1%, very perfect with ROI of 0 years. So we also can do a lot of different measures annually, gradually, but the similar idea is like that. You spend a lot of time in calibration for your model. So for this study, the feasibility of energy saving measures have been evaluated in terms of annual saving and also the payback years. The payback years can be measured like different approach, like high performance chillers, decreasing the water temperature, increasing the supply temperature, or the reset of your room temperature. Not only for the energy saving, but also for the payback year. You can evaluate in advance before the retrofit plan. So those analyses can be beneficial, and as your reference to establish a feasible retrofit plan for energy efficient hospital building. It concludes my presentation today. Thank you very much.
Thank you very much.
Questions?
Yeah, I have only one question. Why you have mentioned the true capacity of the chiller? One is 540, one is 250. Can you not make the same capacity? Or any specific purpose you have?
Why did you specify two capacities of the chillers? Why they are not the same?
I got it. Because this is the existing system there.
Mm-hmm.
Actually, I don't think it's a good system, but it's just there. And I can imagine at that time it's two kind of system. One system is for the regular area, like the office or patient area.
Mm-hmm.
Another small one, chillers, is for very unique, like a critical area, like ICU room, operation room, or emergency room. So it runs 24 hours.
No, that's okay, but what I'm thinking, I'm also thinking some new project.
Yes.
Some emergency, is it not required for emergency that 250 ton chiller? You make an emergency means you have to connect it with the generator?
Yes.
You think in that way, maybe that was the purpose.
Yeah.
That's why you get a total circuit loop.
So
One of the engineers told me only I can do the chiller.
So
I
for
don't
this
know.
kind of
You have
purpose,
to
we
make the
think about
total system.
absorption chiller to reduce the power generation from the diesel engine as well.
If the
Yeah, for
requirement is there,
emergency use.
yes, if the requirement is there, then I have to do the total system with the connection with that.
So this is the
Emergency
reason
system.
why we cannot have a 500.
No, that's why, because I have the same problem, I'm thinking for some new design, that's why.
Yeah,
This is the way, because somebody does not know. Simple saying, okay, I can do the chiller on, you don't know.
yeah.
Chiller have a connected load with the pump with the A2, so I have to make the total design, separate group I have to design.
So nowadays, some hospital is thinking about absorption chiller, which is not so
Western energy point of view.
economical in Taiwan because the electricity bill
Yes.
is not, electricity price is not so high compared to the thermal energy.
But one thing I
Okay,
want
can
to.
we allow somebody else to come back to you?
Okay.
Can I have another
Yeah.
question, please?
Yeah, just about the calibrating the model.
Yes.
Did you actually have like load data from the chiller for 3 years or something?
Yes, we have.
Wow, how did you get that?
Yeah, we have a beam system.
Okay, and they logged it every half hour? or
Yeah,
something?
but not so precise.
Okay.
Sometimes they got, because in the actual world, we got a lot of problem, technical problem, like interruption, combination.
Yeah, but you had something. And,
Yeah,
and
but
what about the weather?
we try to.
How about the
we-
outside? Did you have outside weather data that at the
That's for
same
sure.
time?
That's for sure. We have a TWY. It's an annual data.
Weather
right?
station.
Yeah.
Wow, you're very lucky to have all that there to help you.
It's quite common
Okay.
for the energy modeling. You just download some data yearly from every area.
Typical monthly.
And you also can buy from Ashway, but we have from our weather bureau. they got the data.
Real time, basically, during the period of your
Yes.
calibration. Fantastic.
Yes. It's
So
the
you didn't have to do any measurement on field about the building?
For the measurement, we just try to validate, not for the field measurement.
Yeah.
The field measurements only for example, we don't have the mass flow rate, another flow rate of the water sometimes. So we just double check because we have a building management system. It's a newly one, not old one, because they try to add one. We got some subsidy from the government, try to have some big data, even though it's not so comprehensive. So sometimes we have a double check, especially for the mass flow rate. We're using ultrasonic flow meters because the sensor is expensive. So normally they got a temperature sensor, pressure sensor, instead of the flow rate sensor.
So you just have a portable ultrasonic and you clamp it on and
Yes.
measure the chilled water
Yes.
right there? Yeah.
Yes.
Rather than those magnetic.
One data.
Thank
No,
you.
no, what I'm talking as a common sense, I'm talking.
Uh-huh. Thank you very much for your comments.
Right, we conclude this session.
Yes,
Exactly.
on time, right?
Yeah.
But the weather is fantastic, you do not feel any bored, continuous lecture.